Alrighty, CNT125, Chapter 11, we're working on the section on data backup. So they start off with, if you can't do without it, back it up. Absolutely. Backup is a copy of your data files, that sort of thing, for fault tolerance and reliability. Absolutely. Hopefully you have a scheme of some sort for your own house, for backing up your data on your systems. So they give us like about 6 steps here on thinking about backups. Okay. First thing is step 1. You want to decide what you're going to back up. Obviously the user data and application data, okay, but you also have other things like maybe configuration settings, application settings, preferences, that sort of thing. Also router configs, switch configs, server configs, those kind of things, access points, gateways, firewalls. Decide what you're going to back up on those, and then ideally where you're going to back them up. That's some of the later steps too. Side note, on our network management lab, we're going to do just that. We're going to back up our router and switch, actually our router configs, using a specific application, a TFTP server, to do that. Number 2, select your backup method. How are you going to do this? Is this going to go to a specific on-site backup that we're going to save, or are we going to be using a cloud backup, a third-party vendor to manage our backups? And again, every facility, every site, there might be some pros and cons for each one of these. Okay. Step 3 then. Actually, here they have a whole slew of thoughts on that on step 2. I jumped ahead of myself there. What hardware and software is compatible with what you're using? Make sure you do have some sort of error checking techniques. Yep. Make sure there's sufficient capacity with some room to grow for what you're trying to back up. Be aware how your backup process affects your normal system and network operations. You know, if you try to do all the backups at 8:30 in the morning after everybody's gotten there to work, well, that's just not very good. That's very disruptive. Might it be beneficial to do it at 7 p.m. after everybody goes home? It might be. So think about, you know, your backup processes when they're going to occur. Purchasing decisions. You know, if we're going to use a certain method and maintain that over time, is there a recurring cost we need to be thinking about, whether it be a third party or buying additional storage media or drives or whatever. How much manual intervention is required for this? Is this something that somebody is going to make this part of their job every day, every week, every month, every year, or is this something that can be automated in some way? Making sure you're making wise choices on your storage media, advantages and disadvantages of each one. When storing data to hard drives, recognize drives can be installed on computers, local, WAN, NAS, etc. So maybe there's a better way. Instead of storing on this system, maybe this can go in a NAS or a SAN or whatever. Keeping your backups is secure, including the backup media. Let's say I am backing up to a specific type of tape or whatever. That tape should be stored off-site in case we do have a disaster at the company headquarters. My data backup should not be there. It should be at another location in case there is an issue. So step 3 now then is decide what type of backup will be done regularly, and that's where they bring out the full incremental and differential backup. Full backup, everything every time is backed up. That is time consuming, but it is quite thorough. Well, if I did that every single time, my backups would take hours and hours and hours. So what often gets done is after a full backup, other types of backups get done until you reach a point where another full backup needs to occur. So you run into an incremental, only data changed since your last backup. So I do a full backup on Monday or Friday. During the rest of the week, I might do these partial backups, these incremental backups. And then the differential is data that has changed since your last full backup. Okay, so what ends up happening is you start making a scheme for yourself of, okay, back up everything on blah day of the week. Maybe it's a Friday or whatever. And then these other type of backups are done until you get to the full backup again. And that way you're speeding up your backup process, but you have all of the changes through the course of a week. Number 4, decide how often backups are needed. Is this something that's done daily, or is this something that's done little incremental backups all day long and then a big one at the end of the night? Or is this something that each night you do a little one and then you do a full one at the end of the week? Every facility will be a little bit different on what it needs. So then develop a schedule. When is this going to occur? What time, etc. I threw this in. This was from one of our old versions of the book. It talks about your grandfather, father, son method, showing you when your partials and then your fulls. Here's your incrementals are done, Monday through Thursday. Friday you do the full backup. And it's showing you kind of a scheduled day of the week, day of the month, to you basically have all the pieces that if you have an issue, you can say, okay, well, if we have a failure here, I can bring this last full back up here, these 2 partials, and I'll be restored right back to this day where we lost a drive or whatever it happens to be. And number 6, regularly verify backups are actually being performed. Maybe check your logs, maybe check with people, check your process, make sure these are getting done and stored and so forth. So that brings us to some storage methods we can use. We can use a NAS or a SAN. A NAS is your network attached storage. It's basically, for lack of a better term, a file server sitting on the network that people can save to. This is really just a unique type of server dedicated to data storing and sharing. That's its function in life. So it does have these advantages. You can optimize it because it's designed, that's all it's really designed to do. Store and retrieve data. It's adaptable. I can use in different types of operating systems. A lot of times you can store files in there from different types of operating systems. So it can be sitting there and I can be saving from Linux and Windows and Apple on that device. Expandable. A lot of times you can buy this where you can add hard drives to it or upgrade the size of hard drives in it as time goes on. And I think I do have a picture here. Yeah, here we go. Here's a NAS. Here's a NAS. I think this is the picture the book showed. Here's another one here. These are our hard drive slots that I can be adding into and expanding the capability. And you'll see on the back, it's not the back of one of these, but it's just a back in general. You see basically a network port as the power cord, network port, and that's pretty much it. It's just designed to be plugged into the network and accessible. And here was a home example of everybody kind of saving their data to your network attached storage, just to get you an idea of where that falls in there. So normally, when I have these multiple hard drives, RAID gets used so that we have some redundancy of our data between the hard drives. And RAID is redundant array of inexpensive disks or redundant array of independent disks for redundancy. And you have 4 main types: RAID 0, 1, 5, and RAID 10. So RAID 0 is just that. I have I shouldn't say just that. RAID 0, I have 2 drives, and the data is basically scattered across the 2. There is only 1 copy of data, but it's stored across 2 drives. The idea is it's faster to store. There's no redundancy there, but it's faster to store the data. RAID 1 is mirroring. Whatever's stored on drive A gets copied to drive B. So now I have some redundancy in case one of these fails. I have everything on the other drive. It's going to take time to copy the data on there, but I now have some fault tolerance. RAID 5, you now have data striped across multiple drives, and parity information is added, and the parity can be used to recreate data from any one drive if it fails. So now I'm storing my data a little bit quicker, spreading across multiple, and I can recreate or retrieve the data if one of these drives fails. In RAID 10, I'm using multiple drives, 4 or more, and it's mirrored within each pair of disks and then striped to multiple pairs of disks. So again, it's the idea of getting copies, but also across multiple systems for faster store and retrieve, if you will. Those would be all things I would use in a NAS for my multiple drives here, giving you an idea. That's why you have all these hard drive bays. Okay, so that's your NAS, your network attached storage. That works for many networks, from home to small business to even decent sized schools and that sort of thing. If I now need to deal with massive amounts of data, storage and retrieving, I might use to a storage area network. And just kind of maybe think an example. If you have home, I can have a network attached storage sent, put my data on, retrieve my data. Small business, same thing, even up to a school. When you start moving into hospitals where you have truckloads of information you are storing, scans, CT scans, MRIs, all those kinds of things that you're storing and retrieving and storing and retrieving, you might actually move into the storage area network category. And the storage area network is just that. It's like a network of storage, for lack of a better term. So now I have multiple storage devices connected to multiple servers for sending and retrieving. So I now have, here was your network attached storage, all your devices connected to a switch into a network attached storage. There's your network attached storage. Meanwhile, your SAN, your storage area network, I now have my devices connected to switches, connected to the network, connected to servers, and the servers are really there to take the data and store it away or retrieve it. So these can act as almost like middleman to get through the storage area network to our storage from different medias and retrieve. So they kind of end up being like middlemen, for lack of a better term. They're extremely fault tolerant, but and extremely fast, but they're also rather expensive. Some of these technologies are rather expensive, and there's 4 different ways we can do this: Fibre Channel over Ethernet, iSCSI, or InfiniBand. So let's take a look at them real quickly, just for familiarity. That's all I'm going to look at, familiarity. Fibre Channel is, it can run over copper and fiber, but most times fiber is used. I now have a network of, this is the picture they use, but if I look here, I actually have these would be switches here with fiber optic cable running between the servers and your storage medium. And the catch here is all of this is like specialized fiber switches and fiber connections to do that. There actually is Fibre Channel switches to do that. So it is rather costly, but you can have 256 gig Fibre Channel network. Rather fast storage and retrieval of data. You can have Fibre Channel over Ethernet. This is newer. Allows Fibre Channel to travel over Ethernet hardware and connections. The idea is, trying to get rid of the need for all the fiber connections and Fibre Channel switches. I can run across my existing hardware that I have, and your Fibre Channel frame is encapsulated in a Fibre Channel over Ethernet frame, which is then encapsulated inside an Ethernet frame. Okay, so we have a little bit of encapsulation going on there to allow our devices to share on a Fibre Channel network that's running over Ethernet. iSCSI, this is an adaptation from SCSI. If you think back to earlier hard drives, you had a SCSI connection from the motherboard to the hard drive. iSCSI is a transport layer protocol, runs on top of TCP, can work with twisted pair Ethernet network and ordinary Ethernet NICs. And here is, it's not as expensive. Can already run on established LANs by installing iSCSI software called an iSCSI initiator on network clients and servers. And your training on this is relatively minor. So here is actually a iSCSI adapter. All I would need to do is put that into my device here and do a little bit of software, and away we go. So devices could be sending to iSCSI initiators and storage away, and this just kind of shows you the whole iSCSI initiator, where this falls in the OSI model stack. And InfiniBand, this you're back to needing specialized hardware, very fast, tends to serve very few niche markets. So it's not so common. Here actually is an InfiniBand switch, InfiniBand cable, InfiniBand adapters. So you have some specialized hardware and equipment for this one. So kind of a niche market for this stuff here. But again, all in the name of storage large amounts of data, quick storage and retrieval of data.